Hi, my name is Teresa Stiles, and this presentation is on dyslexia. I chose dyslexia because as a future educator, I wanted to make myself aware of this disorder and how it will affect the students that I plan to be teaching. For information purposes, I'm going to give you the definition of dyslexia. Dyslexia is also called a developmental reading disorder, and it is the disorder that occurs when the brain does not properly recognize or process certain symbols. And by this being a life systems class, I wanted to relate that to how our life systems is affected by this disorder. In the brain, there are activities that go on. Well, first let's talk about the chromosome. There is the chromosomes 18, which is this chromosome right here. There's a study currently being conducted, it started in 2008, that shows a correlation between activity in the 18th chromosome and dyslexia as we know it. It's not the ring disorder that I previously studied about, but this has a significant effect because that study that they're currently doing will help future generations be able to detect whether or not there is a gene that predisposes a child to the susceptibility of dyslexia. It's not only limited to dyslexia, it's not only limited to reading, but it's also a math learning disability as well. How is it diagnosed? It's diagnosed by several assessments, but the symptoms of dyslexia mimic symptoms associated with other learning disabilities. Therefore, you can't just generalize and say, oh, this child has dyslexia because they're exhibiting some of the symptoms. There's a very precise assessment that will determine when and if a child has dyslexia. Dyslexia symptoms include difficulty with determining the meaning of a simple sentence, recognizing written words, rhyming, and it may be in combination with written and math learning problems. What I found interesting about dyslexia is that people, high functioning, high intelligent people have dyslexia, and some of them have been undiagnosed. They don't even know it, but they lived with it. For example, Einstein, the actress Cher, Tom Cruise, Walt Disney. These are just some of the people that have this disorder and have, I guess I would say, resounding success in their lives and in their careers. Treatments are a specialized educational plan.
You want me to?
You can go forward if you like. This is just a simple photo of a non-dyslexic brain and dyslexic brain. Notice that the periotemporal, or the word analysis in a non-dyslexic brain, as well as the occipital temporal, where you form your words, are active here, but not in a dyslexic brain. So this does have a physiological foundation or basis. It's not just, oh, he's dumb, he can't read, or he's not cognitive. This actually, there is a medical tie-in. Although there is no cure, with a specialized degree of assistance and intervention, a child can lead a normal life. Again, like I mentioned, the success rate for children that have, or even adults that have it, is very high. You don't find a whole lot of people that die from having dyslexia. As a matter of fact, I don't recall in my research a case that was recorded. There's a short YouTube video where two doctors are doing brain scans. And these
At Amway, positivity starts on our own organic farms. Farms where we harvest plant nutrients for our top quality products.
These brain scans that they're doing is
Products that help
is
people
very
lead
current
healthier
research, but they're actually watching the brain to see what actually happens to a child that has dyslexia during the reading and learning process.
What do people eat? Plants and animals, I don't know why. Good.
For 11-year-old Mac Upchurch, reading is a struggle, and the root cause of Mac's dyslexia is a mystery. The Dyslexia Research Trust says the condition affects everyone differently. That's made identifying who would benefit from deep intervention extremely difficult. But researchers at Stanford University may have made a breakthrough in identifying which children will overcome the handicap.
What we found was using these brain imaging methods, we were able to predict with over 90% accuracy which child would learn to compensate on a one-to-one basis.
Researchers know that the brains of some children can learn to compensate for the disability. But which children will respond and what parts of the brain are doing the heavy lifting are still unanswered questions.
I think it has yielded accurate results that there is a brain-based marker that may predict outcome. However, we don't know whether increased activation in the right frontal region actually reflects changes in reading processes or some other cognitive process like attention or working memory that may also be involved in reading.
Little Mac is responding well to tutoring, and he's expected to eventually accomplish average reading skills. But Mac's mother says had his outlook been bleaker, she would have sought out additional resources.
If I knew that although I don't think this, but if I knew that your reading skills were not going to improve, I think that we would have to really start relying a lot more on technology and trying to figure out how we were going to make it work.
And that's where the research underway at Stanford comes in.
If we can scan each child before they go through an intervention, we can look at their brain patterns and say, oh, maybe you will be most suited for this intervention. Maybe you will be most suited for this other intervention. And we might be able to one day individualize interventions.
Researchers say their work won't change the lives of people with dyslexia now, but hope that one day it might help complete the picture of how the human brain works. Rita Foley, The Associated Press.
All right. And the intervention that she mentioned in the video is a response to intervention. As educators, we are kind of familiar with that. It's where you track a child's progress and you utilize different strategies and methods in order to assist the child so that he or she will achieve learning success. Does anyone have any questions?